Okay, we are live.
Okay. There we go. Yes, I got the correct window. Cool. So hopefully you can all see that. Welcome to session 5. Let me just move that out of the way slightly. Okay. So yes, session 5. I should say today, I think there's a little bit less in terms of material, so we may be able to finish earlier. I think for those of you who've had a very busy week, maybe you'll be glad to break slowly earlier. But as always, what I want to do in these sessions is to get people to think and to give people a chance to sort of go outside perhaps what they normally been looking at as part of the program and get some experience of other things. Also, today I'll show you the topics here. I'll start off talking about Protocol because I think last session I had meant to go through it and I didn't really get time. I think I had to cut it a little bit short. So I wanted to make sure I give plenty of time to that. So that's what I'll be doing. So it's I'll make a start with that. Starting off with what's been happening. The latest blog post I think we looked at last time. So the timing of this is slightly difficult. So I think we've already seen the latest blog post, but I've got a link there for the February updates. I think there's going to be a new update in the next few days, so we'll have to sort of check that out in the next session. Other things that have happened: the testnet or the road to upgrade is that's continuing. They're coming to the end of that, I think. So there was a final part kicking off, which that would have been last Monday. So that's going to run, I guess, for about another week, and then hopefully that'll be finished. So that'll be good. Another step forward there. Other things that have happened this. Although this actually we'll talk about ZK oracles a lot more next time, but there was this announcement this month about this project who are doing oracles generally for Web3, I think, but they've done a POC and there's a blog post. Let me just check that link. There's a blog post. Yes. So, go away, medium. Yeah, a blog post about that. So be worthwhile having a look at that, particularly because next session we'll be going through oracles a little bit more. So worth having a look through that. Another announcement is the BlockBerry API has launched. So this is to allow people to get data about different chains. So it gets data from many chains, but we can get data for Mina as well. Let me just check this. This was the yes. So that was an announcement. This is details of how to get started with Mina and what is available. So I've got actually some of this linked there anyway, but it means you can, for example, get details of accounts, etc. Get balances for accounts, all this sort of thing. You just I think you need to put in, you need to get your key, and then you can use the API to get whatever you want. Really, there's quite a lot available, as you can see. Some of it, I think. Let me just go back. I'm not sure it's all available or not. Let me just check the. Yes, okay. So I think they're waiting. So they've got these pricing plans. They're going to wait for those to launch to get some of the details there. So it's not. I guess it's not fully available, but it's certainly going to be very useful there anyway. So yeah, there's a little screenshot there for you as well. So very valuable. Okay, all right. So that's some of the things that have been happening this month. And so I want to now go on to talk about ProtoKit, because, as I said, yeah, it was last session I didn't really get a chance to go through it properly, and it is something that I think quite a lot of people are on the program are using or thinking of using, and quite a lot of people are using it generally. It's a great success story in that it came out of, I think, cohort 2, but quite an earlier cohort anyway, or an earlier builder program, with a couple of people who were working on, there's 2 people working on projects and realized they were pretty much doing the same thing, and then they joined forces and went on to build ProtoKit. And I spoke about it a little last time because I was explaining about layer 2s and how they work, and that really is what ProtoKit is providing. And the rationale behind it is, or some of the motivation to want this, is to do with some of the problems that people that we can get around sort of synchronize how getting race conditions, and the fact that multiple users may be trying to update state at the same time, and how do you cope with that? How do you handle that in a safe way? Which back in session 1, I spoke about this a little and talked about one approach, which was using sort of actions and reducer to handle that, and as a sort of a pattern to do it. And this, I should say as well, I got these screen grabs are from some slides from a presentation by ProtoKit. They're much better than I will be able to draw. So this gives you an idea of the current situation that we have on Mina, where what it boils down to is the fact that there are when you're sending in your transaction. So down here we've got Alice, who is doing some computation, incrementing a counter, and as part that's going to then produce an update to state, and obviously get a proof as well. So she sends off the transaction with that, and then when that is received, we need to do this check on the preconditions to make sure that computation was the preconditions for the computation are still valid. And really, this is the point where we could get problems if somebody else has sent in a transaction and the preconditions have changed. Then this is going to fail. So sort of handling this safely and avoiding race conditions are the motivation behind something like ProtoKit. Also, if it does come into what we spoke about last time, which is the idea of storage as well, and off-chain storage, and how, well, that's also the kind of same problem, I guess, but that is another advantage that ProtoKit supplies, as we shall see. So yeah, we get this problem of synchronizing updates without race conditions, and we have to be able to handle that. And so what ProtoKit have done is to build this layer 2, which or build a framework for it, which allows you to create your own app chains, your own layer 2s, which you will then they have their own execution environment, a special VM. In one other thing that they do slightly differently is they have a hybrid execution mode, which I'll come back to and explain what I mean by that. I'll give an example of that. So there is the possibility of on-chain execution as well. Where we tackle the problem of the concurrent updates is the fact that we have a sequencer involved. So the architecture is very similar to the other L2. So we, sort of similar to them, we also have a sequencer, and as the name suggests, a sequencer is there collecting the transactions and putting them into a sequence. And so that way we have a determined way that the updates are going to be applied to this state that we have. So that's a way of perhaps making it a little bit more rigorous, a little bit well, I don't know, less random, I guess. Yeah, making it a little bit more straightforward. Other things about Protokit, it's they've taken a very modular approach, so you can customize details about the app chain that you start up. For example, you can change how the sequencer works, I think, and change about the mempool, etc. And then the other sort of big advantage to it is that it allows us a large amount of on-chain storage. So we're not restricted anymore to just 8 pieces of state within our contract, where we can effectively have, I guess it's not quite unlimited, but for all intents and purposes, really as much storage as we like. And what they are doing is all the details of how things are stored, it has been abstracted away, so you don't have to really to think about that. It's they've got the goal of trying to get the developers to really to focus on the business logic and not have to worry too much about how things are being stored. So they've put us kind of an abstraction on top of that, and but you get pretty much as much storage as you would need. So so what you can do then is to create your own app chain, and then that gives you all of the components that you would need. You need for an app chain, you need for a layer 2, such as a sequencer, which is going to control the mempool and sequence of transactions. It's going to coordinate the production of blocks and do the interaction with the layer 1. And in this case, the layer 1 is Mina mainnet. We get the execution environment where our code is going to be executed, and we have a contract on Mina where there will be settlement. So that's the traditional pattern that we have with layer 2s, where we're sending the roll up to the layer 1 to settle there, which is what. So yeah, so the process then that you get to when Alice is wanting to do an update is shown here. So if you start off, you do some. Here we're going to transfer a balance, and it may be that if it's a very simple call, then we can just have that and sign and send that as a transaction, which will then come into into your app chain. The sequencer will get hold of that transaction and can send that for execution, so that applies the balance and produces a state transition. In this case, the underlying state is a Merkle tree, but you don't have to think about that. It's just that's abstracted away for you, and then that gets then that forms part of the state transition for the block, which then can then later be used to create a block proof, and then all of that is then sent off to the layer 1. So that's there. This extra part here, is to do with this hybrid execution environment that I said, because what Alice can do, this effectively is saying we're going to do some on-chain computation, this sort of simple thing that I've just said. But the other thing that you can do is have a mix and do some off-chain computation as well. So Alice could do some private computation, and from that create a proof that computation has been done correctly. That proof can then form one of the inputs to the transaction that she is sending off to the layer 2, and then that can be applied as well. So we have that option, and yeah, I can go through a little bit more in a second. Now I can show you what it looks like. So I think I've got details further down of the starter kit. So if you install that, you will see something like this. Hopefully, are you seeing? Yes, you are seeing the right thing. So what that, if you install the starter kit, it's a simple project. You'll see something like this. So this is the source code. What is that to tell you about? There's details about how to run it there. I've also put that into the notes. Yes, config. Then in terms of the TypeScript files we have, let me go through this. This one is where we write our business logic. And what I wanted to show you is that some of the imports we do come from O1.js. So we are still using some things from O1.js because this is capable of creating a proof that is being built by Kimchi. So some things come from there, but then there are extra things as well that come from ProtoKit. So you can see here these imports here are from ProtoKit, and so the differences we have are to do with the state, which is understandable because that's one of the extra things that ProtoKit is adding, is the idea that we've got this underlying state that's available for you to use, and then also the assert statement, which I'll come back to in a second. So yeah, that's that. This we've just got the other things are around setting things up. Actually, I'll come back and show you in the test. It's easier, I think. So, oops. What this is doing is around just having a very simple balance. So the state we have here, we have this map that we're creating, which is holding balances, and that's taking as a key an address, and then we have a number that is the balance for that particular address. So quite straightforward. So this is how we show state, and we do that from, here we want the state map because we have we want some key value pairs, but we could do that from state and have create other data types as well. So that is what the program is about. Oh yeah, so here you've got the example of state coming from just a number. So this is the circulating supply. So this is how we can specify our state, and obviously we've got this thing. We can just have a map within our contract, which is very, very nice. We don't just have to store a commitment to it, and so all this code is doing is around updating a balance. It's very straightforward. So yeah, going back to the test, that's what the test is doing, and yeah, so you can see what we need to do for the test. We can start the app chain. We can set up keys for Alice. So we're creating a private key and a public key, and setting up so that then Alice can send transactions to the app chain. This gives us a way to find the state on the app chain, and then we can send a transaction off to the app chain saying that we're going to add a balance for Alice, and it's going to be 1,000. So that's the transaction that we're creating, and we sign and send that. Then we can tell the app chain to produce a block. And the other thing that we get from this is we have this query that we can call that will bring back details of the state from the chain. So we can query the state once we've sent our transaction. So you can see we're going to get the balances to get back Alice's balance from that, and then we can put some tests around that. Okay, so that's sort of very simple a contract looks like. Yeah, as I say, the differences you just have to be aware that we have some extra things that we need to get from ProtoKit. The assert, the reason we need that specifically from ProtoKit rather than O1.js is that it's handled a little bit differently, and this is something that we see on other chains as well. On Starknet, they had this problem where we have to decide how do we want our layer 2 to respond if a transaction effectively reverts. What should that mean? Should that mean that we don't want to include that in the proof of the state transition? And what I think what is generally thought, and what ProtoKit have done as well, is to try to get the idea that even if a transaction reverts, we still are going to prove that the execution of that, including the fact that it's reverted, has been done. That should be part of the proof. And this is also a change that Starknet did with a later version of Cairo and it helped prevent a denial of service attacks that you could get otherwise. And so for that reason, the ProtoKit have got their own assert, which allows the transaction to, or it prevents the state being updated as a result of the transaction, which is what you want. You don't want the state to be updated, but it still allows that to be part of the proof of the when we send up a block proof, etc. So that's why we have a different assert here. Okay, so let me go back to the notes. Yeah, so those are the some extra features you get from ProtoKit. And as I said, because we've got this possibility of a hybrid execution environment, we can do some private computation off-chain, and then that can create a proof, and then that proof can then be sent off as part of the transaction. So the way that would happen is that we would do our off-chain computation with some private inputs, and then that would create a proof, and also we would get a public output from that proof as well. Then we can submit that proof to the sequencer as part of the transaction. So we're following this top path here, and then that gets included in the transaction and sent off to the sequencer. And then the runtime module can then verify that this proof is correct. And obviously, you can make a decision, and then what it wants to do. If it decides that proof is not correct, then it doesn't have to apply the output. But if the proof is correct, then the public output that we get from that proof can then be used further on in the contract, can be applied to our state, or whatever, however we want to deal with that. So yeah, that's the other possibility we have. So that's the private part of the sort of execution, and then the other part is the public part that I spoke about earlier. So I hope that hope that all makes sense. Okay. So if you want to try it out, then there's a starter kit, and that's really what I was showing here. This repo is what you get from the starter kit. There's details there of how to get it from the repo and how to set it up and use it. I did have some slight issues with it. I think using npm works better. Yeah, I think I had problems if I was trying to use npm, and then also there was I think I had to change this configuration slightly, but it maybe I had an old version, and then you should be able to see details of that. There's a good video I've linked to there, which goes through. It goes through the slides, which I've taken some screenshots from, but it obviously goes into a lot more detail and explains everything about the original problems that people have had on Mina, and then how that is solved by ProtoKit. It also then goes on to give an example of a private airdrop. So how you would use this, and this also includes some private computation, so it shows that hybrid environment. And it's nice also that within that they use the nullifier pattern. So I think I spoke about this maybe a couple of sessions ago, that this was a useful pattern to have available to be aware of, so because you can use it in many different circumstances. And so yeah, they used it in this example of the private airdrop. So yeah, do check that out. That's a good resource there. They've also, I mean, the ProtoKit team, they're very active on Discord, and they produced a thread about ProtoKit generally. They also do quite a few events. They had one a few weeks ago where they just talking about ProtoKit and giving an example of writing some code. So do check them out, and yeah, make use of the resources. And they're very active on Discord and very happy to answer questions. So well worth getting in touch with them. Okay. This brings me on to the roll-ups generally. I mean, we spoke about this a little bit last week, but also I found this article let me close some of these things. I found this article as well, discussing roll-ups and how Mina fits into that. So yeah, you can have a read of that. There's a link to that there. But I thought their conclusion was worth highlighting here, and it does point out that one thing that I think has become obvious is that zero knowledge technology, ZKP technology, well, it's obviously been around a long time, but there was a great focus on using it for scaling. When Ethereum was having problems with scaling and started to look to roll-ups to solve that, then that obviously one of those types of roll-ups is a ZK roll-up, and so that sort of focused a lot of or became a big use case for ZKP technology. But obviously it goes much wider than that. It's capable of much more. And I think Mina's in a very good position, and because they started out very early on, and they were investigating some of the techniques that other chains have later picked up, not just ZK but also around recursion of ZK as well. I think there's a lot. It puts them in a good position to use many different aspects of the technology. But certainly, one of the aspects is the roll-up idea, which has been very successful, and it's certainly good to be aware of that. So do have a look at that article as well. It's a useful article. Okay, and that brings me on then to talk about decentralization, and this is where we sort of broaden the scope a little bit, because I talked about this a little bit in the first session, but it is something I do want to emphasize generally. I think with these sessions, one of the overall aims has been to try to provide, as I said earlier, sort of give you more experience of other things that you may not come across generally. And I do keep coming back to decentralization, which is really why we are all here. We are very much focused. When you write applications for any blockchain, you're very much focused on what the business logic may be. But it is please don't forget that we're doing this on a decentralized system. We're not using traditional technology for this, and that gives us opportunities and features that are well worth exploring. And this first part here is some of the ideas of what decentralization gives us. This is in a very, in a very broad sense, very abstract sense, of the kinds of things. So certainly participation, and I'm going to keep coming back to the idea of participation because I think that's very valuable, and certainly one of the things that where Mina really has an advantage, I think, is around participation. There's also the idea of diversity, in that I think this is because we have the types of networks we use allow many different people in many different backgrounds and circumstances to be able to join a network, but also some of the technology used within the network can be quite diverse as well. The third point there about conflict resolution is more about the details of how we come to consensus with these systems, and the fact that we can resolve conflicts or disagreements around the state of the system in a very deterministic way. And really, that blockchains wouldn't work unless we did have some means of doing that. I mean, that is the problem that was solved when Bitcoin came out, and the reason that we have different consensus mechanisms is that they allow us to do this. They allow us to come to agreement, even if there's potentially different state or views of the state of the system at a particular time. The flexibility, I think, is in some ways it's debatable in some ways, but decentralized systems can be more flexible because we don't have some central authority, so we can just add innovations and try new things as we see fit. Some of the problems you do get, though, are because you don't have a central, there's no central authority, then we do get things, problems like scalability. We do get problems if you want to update the system. If you want to update the general, the software that's running, or make some kind of soft fork, that becomes more difficult. But the final point, and the one I think that's the one that I find most important, is the fact that we can move power to the end user, to the edge of the system, that you very much have control over what you are doing with your application, and the assets that you have, and the data that maybe represents you is very much under your control. And so all of these these aspects are worth bearing in mind and remembering when we are designing systems, and making sure that we take advantage of these, but also to avoid centralization and the forces, because there are forces to try to decentralize. And it's just, I think for developers, it can be very easy to come back and to write and design systems in a more centralized way. So it's worth thinking about that and understanding and resisting that. So in terms of participation, it's interesting. I just a few minutes ago saw an article that just from the BBC about Bitcoin, which was saying it gave the number of Bitcoin holders in the world, and it turned out to be about 1% of the population. So, which is not a great deal, obviously. That's a very small number of people owning Bitcoin, and that tells me a few things, I suppose. One is that we've obviously got a long way to go getting people involved in this area. It's also shows really that often how easy it is to get into a bubble when you're involved in the Web3 space, and you're just talking to other people who are involved in this space, and you forget that most people in the world are not involved at all. So that's worth bearing in mind, and I'm sure everybody would agree that we would like to see more people being involved. We would like to see more participation generally, and more people being onboarded into Web3. And there are things that make that more difficult, and depending on what the kind of role that you want to have, there can be real barriers to getting involved, particularly if you want to run a node. And if I look back at Ethereum and what that was like, at one point you could run a node yourself quite without too much difficulty. You could do it on a Raspberry Pi or something like that, but quite quickly it became difficult to do that. The hardware requirements were just too great to be able to do that. And this sort of brings up the question then of what the kind of roles that people are going to have if they are using a blockchain, and how much do they want to be involved, whether they are going to use it in a way that they use traditional centralized systems without too much concern about the decentralized nature of it, or whether they're going to get more involved, maybe wanting to run a node, maybe wanting to get involved in governance, etc. So there's lots of questions around that. If the in terms of running a node, if one of the big problems with that is that if the requirements that are needed to run a node increase too much, then and your node will fall behind. It will not be able to process transactions quickly enough, and eventually your node will lose consensus with the rest of the system. It will effectively fall off the network, and that means that the number of nodes involved in the network will reduce, and so we're getting a centralization effect. So anything that is working to increase the hardware requirements of a system is a centralizing force, which is obviously something to be avoided. And this is why, one of the advantages that we have with Mina and the idea of the succinct blockchain is that we know that we know the size of the proof that we're going to need to verify that. We know that's not going to increase. We've got we can see that, and so we know that we've got a good idea of the hardware that we have. If that can process, if that can check the state of the chain, then it will be able to do that in a year's time or in 10 years' time or something like that. So that can be very reassuring. If you look at the roadmap for Mina, they've got a number of different parts to it, but one of them that is worth looking at is the one of trust minimization here. So just to explain, if you haven't seen this roadmap, it is I do like this. It's a very nice interactive roadmap, but this is showing where we are now, and the green parts are the parts that have been implemented. So you can see, some things we haven't quite got there yet, and then some that we've completed. And then the ones with the red border here, I think these are the ones that are seen as critical milestones. So these are the particularly important bits. But it is worthwhile having a look at where are we going with all of this. And if you look at the end of this, for this particular track here, they're talking about this idea that they want to increase the possibility or the likelihood of people being involved in the network, and also if you're thinking of being a block producer, then this means increasing the likelihood of you being involved and producing blocks, etc. So these are this is definitely where we're heading with that. That's our end goal. And then I just put in the some of the notes here, some of the details from from the roadmap and the article that goes with it, where they're looking forward and thinking about the fact that people would be able to get involved with everyday devices, such as phones or browsers. And this is, I think this is important because, as I say, the role that you are playing then within the network, if you can do that, if you can be running a node on your phone or in the browser, then that's a big step up in terms of your involvement in the system, and it means that we're increasing the participation, but doing that in a very democratic way. And because I think one of the problems that some blockchains have seen is that the participation in the blockchain has been very focused on the developers and has come out of the developer community and has been very tech focused, which I think that it could well explain part of the reason why often we get the sort of the user experience in blockchains is quite poor, because it is being produced by people who are very tech savvy. But if it's possible that people can get involved with very simple devices, then that means that we're getting more people who not necessarily anything to do with development. They're being involved and they become part of the community. So that can be a great advantage. Yeah, so that's just some details there from, I think, from the roadmap and from the article, and it's trying to say that although this may be seen as something of a background to what is happening on Mina and to the applications we're writing, it is a very essential part of what is going on, and this idea of increasing participation is very important indeed. Okay. I'm sure you're all aware of WebNode, the idea that we can, there's an article about here, the Open Mina, and I thought I had a link to open it. Okay, let me go. Okay, I don't have it there, but anyway, yeah, so you can open up the node in your browser. This is an example of exactly the thing I was just talking about, the fact that we can participate very easily with very simple devices. And you can see then that the barrier for entry is so much lower that people would be able to do this very easily. And I'll come back to why this is important a little bit later as well, why people should be involved and should be verifying things and checking the state of the chain. I also just included a little guide there as to what happens within a node as well, but that's a little bit incidental. But anyway, that's there. So what I want to investigate and to kind of do around, I suppose, is to think about and to try to bring out the idea of around decentralization and what it is giving us, and how we can use it, how we can make the most of it. And I took this little table here from Vitalik's blog. It's just useful to look at some systems and some traditional systems, and then see the kind, look at that, how that will be in the decentralized world. And it's interesting to see that the way blockchains have developed, there's often been quite a focus on a particular area for whatever reason. But it does mean that some areas, I feel, are less explored than others within this space. So, I mean, we do, we have a lot of applications being built around DeFi, for example, and certainly that has increased in the last few years. There was the a summer of DeFi, and there was a great explosion of those types of applications, and very much a focus on that. But that's only, that is just one aspect of the kind of decentralized systems that we could build. The idea of DAOs, I mean, that has come back a little, I think, because of DeFi using DAOs for governance. But it's certainly, I think there was, in earlier days of blockchain, there was more interest in DAOs generally as an idea of running a corporation, which has perhaps lessened a bit. They've become a little bit more focused on governance and on DeFi projects in a way. But certainly this is something we could see more of. The ideas around DNS, which, he's saying here about DNS, and that, well, that's one specific thing for a particular chain, but there's there's obviously much more that you could do with that and allow registration of DNS more generally. So there's plenty of scope there. Things around email as well. There's scope. The idea of encrypted email, I think, it's interesting to think, and how many people do use services to encrypt their email anyway, which I guess is quite few. People tend to rely on some big providers to like Gmail, etc. So yeah, that's worth thinking about as well. Messaging, that is I think this is a little bit old, but there are more systems coming around messaging there. Although I think these are often, we do see sort of trends, and one thing becomes very popular, everybody moves on to that. But again, there's lots of there's quite a bit of potential. Sign in, I think this is something that could be very interesting, and I've got an example a little bit later on from one of the cohorts of a project where they're looking at how to do logins, and that could be yeah, very useful indeed. Publishing, yeah, I'm not sure whether I can't think off the top of my head of things in Mina doing that, but yeah, this having content available and doing that in a potentially anonymous way, maybe, or putting it onto decentralized systems is something worth thinking of. Your Twitter, Facebook, just your social things. Certainly, I know Farcaster is very much in vogue at the moment, so lots to be done there. I'll talk about this idea a little bit more generally, the constraining bad actors. But yeah, I do feel that there is still a lot of scope. It's not as if in the time that blockchains have been around, we've actually managed to sort of saturate the solutions in all of these areas. I think there is still plenty of scope for people to build systems focusing on those. So if we're going to do that, why would we do this? What is it? What does decentralization give us? So one thing I've been talking about is the idea of increased participation. And then also is the fact that participation requires fewer resources. So which has, well, that will help increase the participation generally, but also help to get people more involved and involved in perhaps a deeper level with a particular system. If as developers, what can we do to help increase decentralization? So again, I think I mentioned this earlier, but it certainly is worth bearing in mind that centralization is a risk that is to be avoided, and it is still, even though we're working on a decentralized system, it is easy to start to design things in a very centralized way. And so we have to, I think it's worthwhile sort of keeping in mind that the need for decentralization, and to be thinking about how we can best achieve that, and not to sort of get into centralized habits. And one area that I've seen sort of recently is that within audit reports, when there's auditing of systems, that's an area where centralization can be pointed out, and it often is pointed that there's a particular system has the ability to be controlled by one person, and they could then potentially do something malicious. And a lot of the exploits that are happening in, say, DeFi are rug pulls, where we have exactly this thing, that's exactly this point, that the way that a contract has been written allows one person to, say, control the funds, and then they can use that to exploit the other users of the system. So we should be aware of it, and we should try to be thinking about how can we avoid using centralized patterns, such as making certain people or giving certain people a very powerful role within our contract or our system. But also, I guess the auditors need to then also be flagging it as well, and checking that that is not happening. Then this idea of increased participation in the network is certainly needs thinking about, because here again, Mina, I think, has a particular advantage, because because of the architecture, because we've got recursion and the succinct blockchain, we are able to scale more easily than other chains. Often with blockchains, as you increase the number of nodes, you start to get poorer performance, and you start to you're going to have to think about the bandwidth across the network and whether that can support the things that you are doing. So, sending blocks and whatever messaging, sending transactions, etc. Is your network going to have sufficient bandwidth to be able to do that? Because the requirements for Mina are so low, then that gives it a great advantage. Each time we want to verify a block, we just need 22 kilobytes, or whatever the real value is. I know that's not exactly it, but whatever the real value is, especially if you think of something like Ethereum, which I think at the moment is about is it about half a meg for a block? But anyway, with their roadmap, they're looking to do this thing called dank sharding, and that's going to introduce blocks of 30 megs, which is going to be a significant drain on bandwidth. And again, if you come back to thinking about the people who are going to be participating, that is going to certainly exclude a lot of people. A lot of people will not have sufficient bandwidth then to get involved and to support the network. So that's why the fact that we've got a succinct blockchain is very important. It's keeping that possibility for participation open. Also, I want to think then, or to ask you to think about what are the effects of this? What are the effects of increased participations? So it means that we can check the integrity of systems and do that easily. So that could just be a very routine thing that we can do. And this could be very beneficial if you start to then think of if we can just do this generally, and a lot of the systems that we use, then there's all sorts of advantages that could bring. For example, if you have something that is going to act to reduce corruption in a system, then if you would want the ability to check that to become easy. You don't want to have to rely upon specialized people, and whether they're specialized because they have special hardware and they can afford therefore to run a node, or whether they're specialized in terms of a technical speciality. That's something to be avoided. Again, that's a centralizing force. So better than that is if everybody who is using the system is able to easily check that the integrity of the system, and then that means that far more people will be able to check against something like corruption, for example. And I remember years ago the idea, one of the use cases of blockchains being that in places where or in systems where there is corruption, the fact that we have a blockchain can help reduce that, because there is transparency, and it can mean that payments that are being made can go directly to people who should receive them, without parts of those payments being sort of siphoned off, etc. Or when funds are passing between multiple parties, it's then very clear the amount of funds that are being kept by people. So there are many benefits to society that could come from these types of things, but then we need to be able to check this. We need to be able to make sure that this is working correctly. Otherwise, then you could, if you have just a few people who are able to check this, then corruption could affect them, and you could go back to a system that is doesn't have integrity there. So but having said that, something that we probably don't think about too much, but it sort of struck me the other day to think about, was if we are checking these systems. So if you're running a node and you're verifying that the blockchain is working as it should, that's great. What do you do if you find that it isn't, which I've called here the unhappy path? Because we're just assuming that we'll be running a node, checking that the system's working fine. What do you do if you find that it isn't? And of course, you could just not use the system, but that's a very kind of negative reaction, really. That's we want something more creative than that. And I think what we can do then to help with that is to have a very robust governance procedure that will then mean that we can sort of go in and fix problems, and do that again in a way that has very wide participation, and means that we have governance that's not just a few developers who are going and changing things and moving the system in the direction that they want. If we have a very widespread governance, that is to be recommended, I think. But we do need something like that, because we do have to face the idea that our system could have a problem, and maybe when we're verifying, we find that the latest proof doesn't verify, and so what do we do about that? So that's something else that we need. This brings me on to an idea about transparency and privacy. And you may think that in any system that these would be exclusive, but these would be mutually exclusive. But one of the great things about ZKP Tech is that it does allow us to have both, and it does increase our ability to use both of these concepts. This quote I've got here is from Starkware, but I think it shows it quite nicely. It shows that we can use this cryptography, the ZKP Tech, to help us keep data private, and that there is data that should be private. We shouldn't have to have all of our data made public, and so we can do that with zero knowledge proof, with zero knowledge proving systems. But then also, what that does is to allow us to build systems that can give transparency to areas that where previously there would be something that would be used to maybe cover up bad actors or dishonesty, because we can prove computation, because we can prove that things have been done correctly. It is much more difficult to have things being hidden in your system like that. So it provides a very nice dividing line, I think, a very clear division between these two things. And the fact that we can have effective privacy within a system then that gives us more confidence to allow greater transparency within that system, because we know that we can do that without running the risk of giving out private data. So this technology, I think, is really really poised to give us these good aspects to systems, but we have to take advantage of that. We really have to use them. And as to come back to the idea of centralization and centralizing forces, this should be a concern, and it is a concern, I think, for chains, because the blockchains do evolve over time, and some of them are seeing centralizing forces being brought in because of the way they work and the sort of the crypto economics involved. There are forces that could lead to centralization, which is quite a concern. And I think the Web3 community is concerned about this, and they are trying to find solutions to that. And an example that where we could end up, or where this could be particularly problematic, is with the ideas around censorship, which is what we've seen with Tornado Cash, and the fact that users of Tornado Cash, or those addresses, get put onto a sanction list, and then certain, and I'm talking here about Ethereum, certain block producers will then drop transactions from those addresses because of this. And so if you get increasing centralization, then you run a risk of this censorship having a greater effect. We do need to be careful about centralizing forces, and to be thinking about that as we're evolving our systems. But as I say, I think the architecture of Mina, the way it works, the fact that it is succinct, and the fact that it is using zero knowledge proofs as a very core aspect of its technology, really puts it in a good place to help prevent this. And as developers, I think we should be really championing the opportunities that this gives us, and really trying to make the most of the possibilities from this. Okay, so just some ideas that I have seen or come across generally that I just wanted to share, that I thought you may be interested in. One thing that so these are general ones I'm going to talk about initially. One that I haven't seen for a while, and I don't know why this is. It was at one point it was quite popular, which is prediction markets, and then I don't know why it seemed to go out of popularity. The idea behind a prediction market is that it relies on the wisdom of crowds to come up with a sort of a decision about something. So, for example, if it's an election, you could set up a prediction market to forecast the results of an election, and the hope is that this wisdom of crowds idea will allow that forecast to be relatively accurate. I think. Yeah, and so that's the idea behind prediction market. There also was I know the examples given of a way that this could be used much more maliciously, where people would make a prediction about, say, they would predict and say, oh, this politician is not going to be assassinated, and they would bet a certain amount of money for that, which would then prompt somebody to actually assassinate a politician and then claim that money on the other side of the bet. That was always an example that people brought up to say, oh, there's negative aspects to prediction markets, but whether that actually would ever happen, I don't know. But that prediction markets were certainly popular at a time, and seen as a very interesting use case in Web3, and it seems to have dropped out of popularity for whatever reason, but I found them interesting. I think it's an interesting idea. I also just thought it would be interesting whether we're going to see these being where the wisdom comes from AI agents as well, and what they come up with. And I think that could be very interesting, particularly because of the bias that people are seeing in some of the AI systems that we have. It would be interesting to see the types of predictions that they make. But anyway, that's one thing that I haven't seen for a while, so I wanted to mention that. Disintermediation generally was I thought a goal of decentralized systems, and was one of the reasons I particularly liked the idea of blockchains. I thought that we would get rid of a lot of the roles in society where people are acting as effectively agents in between a buyer and a seller or something, and that we could get rid of these people, and this would be a great thing. And it doesn't seem to have happened, but whether we'll see more systems helping with that. Certainly, I mean, with DeFi we are seeing more direct involvement, but whether we'll see more, I don't know. And then the idea of shared ownership. There was the idea of tokenize everything, and that I think that died down a little bit. But it would be interesting to see more imaginative ideas around that, and the things that people could tokenize. Because when people talk about this, they've very much focused on things like digital assets and artworks and things like that, and tokenize those, and maybe things like other things like home ownership, I guess, property, that kind of thing, which is going there. But I think there's a lot more scope. And I don't know if I've mentioned it already. I wanted to share with you something I saw at a hackathon where some people went around. It was in Prague, and one of the winning teams, what they did, they went around and found small areas of land, particularly areas sort of between buildings that weren't owned really by anybody, and they tried to, they didn't exactly tokenize it, but they put a little thing in the ground saying that was now owned by a DAO, and they were trying to like set up so that the whole, a large amount of land within the city could then be owned by a DAO, because it will be collectively owned. So ideas like that, I think, are very interesting, and it would be great to see more of those coming out. Just some things you may have seen. So in the latest cohort, there's some interesting projects. I mentioned the idea of login, this around identity as well. I think that could be quite interesting to see where we can go with that, and whether we can get a decentralized version. So please do have a look at this. The ZK Cloud Worker. Oh, I must spell that wrong. Sorry, it should be Cloud Worker. This was the idea of getting proofs created more efficiently by various techniques. The rate limiting nullifier, I think this is a general idea that's been around in blockchain. It's the idea to help with Sybil resistance as well. So, but there's do have a look at all the cohorts. There's lots of interesting projects there from some previous ones. There's the ZK Locus. I think that's quite well known around. I just grabbed a screenshot there around geolocation and doing that privately. DAO voting, so coming back to the idea of governance as well, and sealed bid auctions. All of these are very useful little tools, I think, that could then be integrated into other things as well. It could be interesting little stepping stones. Also, think like verifying Bitcoin headers is interesting. This brings us into the ideas of interoperability and being able to do things for other chains. And if you start to think about that, and you start to think, well, Mina then could be offering things to other chains because of its architecture, because of the fact that it has a succinctness and it could get this participation, then maybe other chains would want to get sort of integrate or get some kind of interoperability with Mina to take advantage of the fact that Mina is offering that. So lots of possibilities, I think. So please do bear them in mind. I appreciate that. The project you're working on at the moment, you're doing, you've already started something, you're doing a specific thing, but please don't stop there. Please keep going and thinking of ideas and building new things. It's one of the great things I found about Web3. One of the exciting things I found about it was when I came into it, is this idea that it was really a green field, that there's just so many things that you could do that haven't been done before. There's so much that you could explore and try out, and that was very exciting for me, and I think that is still the case. There is plenty that we can try and plenty that we can explore, so please do make the most of that. Okay, so that's everything I have. Yeah, we are a little bit early, but yeah, I hope you found that useful. I'll stop sharing and hand back. Yeah, so thanks everyone, and I look forward to seeing you at the next session. I hope you all have a good weekend and a good week coming up. Thanks everyone.
Bye bye.